people. If different men and women, comparing raw numbers don't mean anything to each other. If you had like 1,000 men and 10 women, and let's say you're measuring how many people smoke, saying like 100 women versus one man, right? You're like, wow, so many women smoke the men, but in reality, it's just a percentage. If you took those two percentages, it's the same percentage of men and women smoke. It's not apples to apples to compare raw numbers because you don't know what the base is. If the same numbers, if the same totals are the same, it's like the same number of people are equal, it's fine. But you're always safer doing proportions. It's one of the ways statistics can lie to you. Okay. So, does anyone have any question on C? What was just said?
Yeah, can you repeat what, I had it written, but I don't think I wrote it down correctly. So can you just repeat it, please?
Yes. So the short answer is to avoid bias. If you have different numbers of males and females, like in this case, which if you look at your frequency table, it turns out we do. We have 147 versus 153. Comparing the raw numbers of each of those groups doesn't represent how many people in the overall population, doesn't represent how the two actually behave apples to apples. You can think of a lot of scenarios where this is the case. Like if I tell you 100 people die of shark attacks, you're like, wow, that's a lot of people. But then I'm like, well, out of the entire world. And you're like, oh, well, that's not very many. It's important to know the total so you can have a percentage, so you can compare. Or like, 100 people die of shark attacks in a country versus another country. And you want to know what the percent of that total population is, or the percent of people in the ocean for that matter. Does that make sense?
So the relative frequency just wouldn't include like it saying female and male?
No, it does. It does include female and male. It just, it doesn't, you can have a biased, like if you say that there's 100, if there was like 1,047 females versus 153 males, saying that like 660 people had normal blood pressure versus, 53, you can't, comparing those two numbers doesn't mean anything because they're not the same proportion.
Oh, got it.
And
Thank you.
Yeah, of course. I know it's a lot of words. I know once you see it, you're like, oh, but all the words I'm saying aren't helping. Okay, we got to move on. Sorry, guys. Okay. So I know I didn't have you work on B, but it's for a reason. The relative frequency, and this really highlights it. Oftentimes they'll be like the same graph. You'll notice they look very, very similar here. You'll have 119, but then that'll be about like 39.867%. You'll have similar things. It's just showing the relative. It's comparing apples to apples. You're like, oh, okay. So instead of 120 out of I don't know how many people had normal blood pressure, about 40% of people had normal blood pressure. About 20% had elevated. This is a better way of describing data usually. Stable on A. Whoops, that's okay. You could just swap them. The cool thing is, for the most part, it's the same graph, just different axes. So it's pretty easy fix. You didn't know how to, someone said they didn't even know how to set up A and B. Okay. Yeah, graphing and tables are something that you're going to want to spend some time with. I unfortunately can't go into the full depth and breadth of table creating. But suffice to say, each of these bars represents how many are in that category on the x-axis. Is there anything anyone wants to ask about this as we jump through this at breakneck pace? I know. Yeah, go for it, Adriana.
The both graphs are it's graph A, right?
Yeah, but one is the left is graph A, the right is graph B.
Left is A and then the right is B.
Yep.
Okay, sounds good. Thank you.
I feel like I want to tease you guys and call one and just say both the word Janica at both of you. Just to really dig in the knife. So what's important here is, you can write down the graph all you want, but it is important that you figure out how to do this, that you learn how do I actually construct these things, because you are going to be asked to do this, if I'm not mistaken. It's a pretty fundamental part of this course, as far as I understand it. Because, and if you're having trouble, if you're trying to copy this down like breakneck pace, just take a picture of it.
I have one more question. Sorry.
Yeah.
The for graph B, the only thing you're doing basically is just dividing it by 300. I think that's how you do it. Like, for example, for normal, it was 119. So you get 119 divided by 300. Correct?
Yeah.
Okay, makes sense.
What's that percentage? Let's find out.
Oh, 0.40.
You want to be a little more precise on these things. You want to try to mitigate rounding.
Okay.
If you notice, the last category has very few people in it, and you never want to round a category to 0.
Okay, sounds good. Thank you.
Of course. We learn how to make one. Oh boy. I sure hope so. If you don't know how to make these graphs, and she didn't share with you in class how to do them, is that correct? She didn't go over how to make graphs?
Nope. No.
I have questions. So many questions. Well, awesome.
So far, what we've been doing is basically just like words and their definitions for like stats.
Okay. Geez, I don't have time to no one apologize to me, please. It's not your fault. I hate to answer this, but I recommend looking up some YouTube videos. Has the other class said anything about this? No, but I don't run each of my classes the same because I'm a different person every day. Every 2 hours I change. Maybe. Okay. Seriously, I don't like to say it. I hate. In fact, it makes my skin crawl. YouTube, how to make a graph. I promise there's some really resources out there that will be more time efficient. I'm really sorry. I know, that's why I hate saying it. Because it's not a good answer. It's a terrible answer. It's an unacceptable answer to give a student.
I have a question.
Yeah.
Oh, wait, are you going to talk about part D next, or?
Yep.
Okay.
I have a question on this one. So where did this might be really dumb, but where did the percentages come from?
They come from, do you know how to do, well, when I say relative frequency, what do you think of?
I have no idea. I'm not thinking. That's the problem. Like,
I know, right? That's a good question. Khan Academy is probably a good place to go. I would try Khan Academy for bar graphs.
okay.
So if you think of relative frequency is where you have if you think about it, the relative frequency of the thing. So if the relative frequency is something, you divide, Jenica, you divide the frequency by the total to get relative frequency.
Oh, okay. Thank you.
Yeah. And when your brain clicks back on in like a couple hours and you're done with this class, and you're like, oh yeah, that does make sense. I know you're in like note-taking mode. I totally get it. No time to think, just copy. Okay. So D. And if A and B were a problem, boy, are you gonna like D. You had a question about D.
Yeah, so you already gave us the frequency table. So it's gonna ask us to make a relative frequency table
Yep,
for the female and male, or is it the total?
both.
Both.
It's by gender.
It's by gender. So let's say in the normal for female and male, you divide 66 by 147 and 53 by 153. Is that how it goes? Or is it by all 300?
No, you got it.
Okay.
So you're basically making two tables put together because you want to compare each category against each male and female. I just realized the next thing has a typo in it. Quick look away. So and I really appreciate the questions, by the way, guys. It really helps. Please, please, please ask questions, because by asking questions, oftentimes you speak for more than just yourself on lack of understanding, and by talking about it, more people will get it.
Do you want us to write out the frequency table on the actual paper, or is having the picture of it enough?
You don't have to write it out if you have a picture of it.
Okay.
So how do we feel about, do people have an idea of how to set up D?
I think it's you create the relative frequency table, which is you take the frequency and divide it by the grand total, which will give you the decimals. And then you can, I don't know if it's optional to change them into percentages or not, but once you change them into percentages, then your relative frequency graph is going to you can construct it then. Do I say the axes as well, or?
You do say the axes as well. I mean, say them,
Okay.
but you do put the axes.
Yeah, I would assume the x-axis would be the different categories of the rows, and the vertical axes would be the decimals or percentages.
Yes, that is the general way to do it. The only thing I would say is make sure that male and female are separated. Comparing male versus female on the blood pressure.
So on the graph, let's say for on the x-axis, it's like normal, right? Can one bar be representing female and then one bar next to it can be the male?
Yes, that's
and then the next is elevated. Okay.
Yeah, that's preferred. Because that way, so in a perfect world, what we'd actually do is we'd give you some data that you actually give a crap about, and then ask you a question that actually matters to you. And then you'd be like, well, I want to know the difference in percentages of these two things. And so how would I best show that? And the normal human response to want to compare things is put them close together. It's easier on the eyes to have things you want to compare.
So to get the relative
No, go.
to get the relative frequency, so if for the female, we would divide the 66 by their total, which is 147, right?
Yep.
Okay.
I'm noticing some people in chat who are very rightfully lost. I am sorry that this is the experience you have today of our course. A lot of this knowledge is predicated on the understanding of how to do graphing well. And I wasn't told in my timeline to teach you to graph things, which is awesome. Because it only means that people who don't know how to graph things are super behind. That's awesome. So to do graphing is kind of this thing. If you're really, really lost on not knowing how to start graphs, really I think Khan Academy has something on bar graphs. There's some good tutorials on it. I don't know why we're not covering it in greater detail. Awesome. That's fantastic. I'm really glad that's great. We're making a relative frequency graph for each gender. So you're making one relative frequency graph per gender. Yeah. Let me show you something. So don't be nervous. So you do have to submit these pages. Don't be nervous. Give it your best shake. Don't panic. Number one, I should just have that as my background. It's just don't panic. You're here to learn. A lot of your points are showing up. A lot of your points are turning things on time. A lot of your points are being engaged. You're not always graded for that many points on correctness. You just have to try. Very few of your points, your grade comes from correctness as far as this activity section is concerned. Give it a fair shake. All right, let me share something real quick. So this is what I'm talking about. This is the graph that we're talking about. So blood pressure versus male and female. Very good. Oh God, first. Don't trip. The important, what you're trying to understand, or what you're trying to get with these graphs is, yeah, you can use, so percent is usually the way you want to talk to other human beings, because when you talk to other people, you're like, hey, 0.347 of something is really in right now. And everyone's like, what are you talking about? And you talk about percents, so like 3.47%. And they're like, I still don't know why you're talking about percents, but I understand what a percent is. But do whatever you want. Percents, decimals, totally fine. What you're trying to show here is there's the how likely, and this is what E is about, how likely the male versus female is. So you don't say that there are more males or more females, you say the likely. It looks like more females are likely to have lower blood pressure. More males are likely to be, it's more likely that males have a higher blood pressure. It's more likely that females have a normal blood pressure. And it looks like hypertension stage 1 and 2 looks pretty similar. There might be some minor differences. And then hypertensive crisis is almost no males. You always round the decimals. Round the decimals to 2 or 3. So in percents round to 2 decimal places. In decimals round to 3. What you want to do is just mitigate rounding if you can help it. Just be consistent. Okay. I know this is a lot. Are there any questions that I can answer? And then we're going to go on unfortunately, only a 5-minute break today, because we are just wildly behind. Do the graphs have to be accurate? What do you mean by accurate? You don't have to, for the graphs, they don't have to be exactly the same as what I did. They just have to be of the right shape. There, do you compare the graphs? Yes. Talk about how likely males and females are to have these conditions, normal, elevated, and so on. For this one, you're using the totals for each gender because that's what you're trying to compare. You're trying to compare percentage of females to the percentage of males.
For the title, what was the title for the graph B? Was there a title or no?
Don't worry about titles.
Okay.
Don't even trip about titles. It's like super whatever. Okay. All right. if there's nothing else, I'm gonna have us meet back here at 107, and then I'm gonna put you in groups, and you're gonna work, and then we're gonna share, and then we're gonna have an awesome Friday after that. Anything else before we part ways for 5 minutes? Okay, so I'll see you back here at 107. Don't leave the Zoom. Stretch, breathe, do a yoga pose, chillax. Thing, and I think this looks like an okay starting point. This is pretty representative of at least the foray. The video seems to be a minute long. So I think you can get something out of it, and it's pretty fast. But you know, where I fail you, I hope your fellow students pick up my slack. Let's see. So what we're going to do is I'm going to put you into groups of 4. You're going to work on problems 3 through 8 for about, I'm going to call it about 30 minutes, a little under 30 minutes. And then we're going to come back and talk about a few of them. I'm going to go around the rooms, work with you on some of them. We won't have a lot of time to share because it's like 6 problems and like not nearly enough time to share about them. But we'll do our best. And if you have questions, so I really recommend if you get stuck on a problem, just skip it and keep going. It'll save you, be more efficient, and you'll probably thank yourself in the future. Any questions before I ship you off to group land? Awesome blossom. All right. Good luck. Have fun. And there you go. We don't have a whole lot of time because that's the name of the game. But I think what I want to use this last few minutes for is, rather than just giving answers and explaining them, because I think the most valuable thing we could do is start with questions people had difficulty on. Like, are there questions that people are, groups were just like, I don't understand this question, or like, I really would love some clarification, or I just love to go over this question. So are there any questions that anybody would like in particular to talk about?
Just to make sure, on 8B, when we divide, how many places did you want for us to round? Decimal places?
3 is always a good guess.
Okay, thank you.
Would 2 decimal places be that much of a difference or no?
It depends on who you ask.
Okay, because I did 2 decimal places.
You'll live. You'll be fine. So what matters too is that you don't round anyone out of existence. The basic tenet of a lot of decimal rounding is you're trying to preserve information so you don't make things look the same if they're not. It's kind of an art. A lot of people just say always use 3, but 3 non-zero decimal places is also oftentimes also a thing. Just 2 or 3, unless it specifies 2 or 3, and both will be fine. I know I keep saying that, but it's really preference, and I don't have a real one about it, and it changes. You'll be fine either way. Okay. So I'm seeing question 4. Do we want to go over question 4? I don't know if you can hear the cat screaming. No? If no one else wants to interject with yes, no, maybe so, we're going to go over 4 real quick. Is any... I only am going fast because we don't have much time. Yeah, Gracie, do you want the whole thing, or do you guys? Or, most people have problems with D, E, and F. Okay, I'm guessing most people, but I mean, we can go through the whole thing. I noticed a lot of people have. I'll go through it very quickly. So 4. 4 is the mean income of all subscribers to a particular magazine is 26,000. We draw a random sample of 100 subscribers and then find their mean income is $27,300. Identify the following. So for A, you have population. And population is, generally speaking, and always good instinct to say all. So whatever all is, however you can define all, is oftentimes the right direction. It's also where the sample usually comes from. In fact, it always will come from the population. So here we have all subscribers to the magazine. Pretty straightforward. Sample, similarly, is what you draw from the population. So it's the 100 subscribers chosen. Parameter. Parameter is the descriptor it's the thing that describes the population. So it's the information that you have about the population. Parameters are rare in the real world because it's hard to know what everybody is doing. But in our case, the parameter is the 26,000 because it's the thing that describes the population. And then statistic is D. This is the 27,300 because this is the information that describes the sample. Think parameter, population, statistic, sample. And then for E and F, where kind of the meat comes from this, is variable and data. So variables are things that change based on your sample and the individual parts of your sample. So if here you have 100 people, and the information you're collecting about them is their income, as it says. And it changes. The variation, the variable of each person is their income. Right. So their individual income, not the average, the individual. The variable in question is income. It's kind of like if you made it an Excel document and you just put variable at the top. That's how you describe it. You put income at the top, and then you put numbers. And then for data, that is the collection of information that you gather from your sample. It's the stuff that when you ask the participants what they have, what they did, or what they are, whatever, doesn't matter. But you ask in this case, how much money do you make? They're like, oh, I make this much, and you write that down. And you go to the next person, you write that down. And you have a collection. So let's say on your clipboard, you wrote things down. You wrote on your clipboard, okay, 23,000, 24,000, 107,000, 4,000. And you just write these numbers down. And that collection is considered the data, that information. And so for here, it would be the income of the individuals in the sample.
So we're not stating like the specific number, we're just stating the income of the sample of 100 subscribers?
Right, because you have no individual numbers to describe the income. You only have a mean. Variable and data are similar. And I know it seems like splitting hairs. The variable is income. The data is the collection of that information in the variable. It's very similar. It's very, very similar. We turn this in midnight Saturday. Of course. Data usually just based off the sample and statistic. No, I guess you could think of it like that, but it's mostly that you get the statistic by analyzing the data. Sample is the random sample of 100 subscribers, yes.
Not related to number 4, but when it asked us to find our comment on our findings, like on that first one we did together, and then the number 8, do we just put like what we see as a trend on the graphs?
Thank you for asking that question. I want you to be comparing the likelihood of male versus female on these conditions.
So for example, we could say like, we see that more males have, like, describing each individual category then with male and female, or just overall?
Each category, yes.
Okay,
So
got it.
males or females are more likely to have this condition, or they're equally likely.
Okay, sounds good. Thank you.
Of course. Okay, someone's asking for the explanation of the data. It is time. With my last breath, I will explain that. Data is a collection of information you gather from the sample. It's a list, usually, of information. Okay. Thank you, everyone. I know we only got to go over like one question, and herein lies the problem of our class. I have 10 minutes between this class and the next. If you would like to stay and talk to me about anything in that time frame, you're welcome to. If you don't have questions, have a wonderful Friday afternoon.